Hello and welcome. In this video, we are going to solve problem number 32 of Leetcode, that is longest valid parenthesis. So in this problem, we have to find the longest valid parenthesis among given set of parentheses. Like we can see that we have written some examples already here. So you can see that these four are the only valid parentheses among these all five given parentheses. We can see in the second example, we have only one pair of parentheses which is valid. In the third example, we can see that there are all the two parentheses pair of parentheses are valid. That means length of valid parentheses is going to be 4. In the case 4, we can see that number of valid longest parentheses is going to be 6. In the test case 5, we can see that there is no such valid parenthesis that we can find out, and its result is going to be equal to 0. So if you can remember, we have solved a similar problem in a previous video, which was problem number 20 of Leetcode, that is valid parentheses. So in that problem, we used data structure a stack. So we are going to use same data structure and trying to solve this problem using that concept that we have already learned in problem number 20. So how we can solve this problem using a stack? Let's see. So let's create a stack and try to solve this problem. Okay, so we will go to each test cases one by one and try to understand. So we have given a set of string like this. So we will start from index 0, and if you can remember, whenever we will found any open parenthesis, we are doing, we are simply pushing that into our stack. So in this case, we have to find the length, so we don't have to push this character. We will be pushing the index of that character. So first we found open parenthesis, we will be pushing that into index. Again, now we will come to second for index number 2, sorry, index number 1, and we will be pushing the index of that, that is 1. Now we'll find out that we have found a close parenthesis. In that case, what we will be doing, you can remember in that problem, what we were doing, that we are doing pop this item from top of a stack. So just pop it out. Okay, now again we will found that we have a open parenthesis. We will be pushing that into our stack, that is 3. Now again we found that we have a close parenthesis. In that case, what we will be doing, we will be popping that out from our stack. So this is going to pop out from our stack. And now, is there anything remaining in our stack? Yeah, there is a index 0 that is remaining in our stack. So how we can find out our result using this index 0? So what is the total length of array? Sorry, total length of a string. The total length of a string is going to be 5. So what we will be doing in that case, we will be trying to 5 minus 0, that is going to be our 5 length, but you know that our string is going to be of length 4. So we will be doing 5 minus 0 minus 1, that is, let's say, if you will pop out, then it is going to be b is going to be 0, and we have a equal to n is going to be in starting 5. So 5 minus 0 is going to be 5, then we have to subtract 1, then our answer is going to be 4. Okay, so for this our answer is going to be 4. So we don't know how we can implement this, but we know that our answer is going to be 4. That's why we did this, like 5 minus 0 then minus 1. Let's try to solve another problem, and after all, we will try to build a algorithm for this using this method. Okay, so again, for second problem, we have, okay, so at starting we will be inserting 0. Okay, then we will be inserting 1, and then 0, then 1, then we will found a close parenthesis, we will be popping out 1, then we will be having 0. Similarly, the length is 3, 3 minus 1, 3 minus 0 minus 1, that is our answer is going to be 2. Okay, now coming to test case 3, where we have valid parenthesis. So we will be starting from 0, we will find a open parenthesis, we will be inserting that in our stack, then we found again open parenthesis, we will be inserting in our stack, again we found a close parenthesis, we will be popping out, again we found a close parenthesis, we will be popping out, our stack is empty. Whenever we will found out that then that our stack is being empty, in that case we can say that all the parenthesis that we had was a valid parenthesis. So in this case we will be returning the length of a string, that is going to be in this case 4. Okay, and let's see test case 4. We have open parenthesis, close parenthesis, open close, open close. Now we'll be starting from index 0 and pushing it into a stack. Again, we are at index 1, pop out, index 2, push, index 3, pop out, index 4, push, index 5, pop out. Now we can see that all the indexes has been pop out and our stack is empty. In that case, what we will be doing, we can say that our all the parenthesis was valid one. So we'll be returning in this case 6. Okay, and for last set of test case, we have all the open parentheses only. So what we will be doing, we will try pushing it all the indexes from 0, 1, 2, 3, 4. All are open parentheses. So we will be pushing all one by one, 1, 0, 1, 2, 3, 4. Now we can see that there is nothing to pop, so we will come after that and see that what is the top element of top index of a stack, that is 4. So we have a equal to 5 for now, which is going to be our length, and b is going to be 4. So 5 minus 4 is going to be equal to 1 minus 1, that is 0. Okay, but we can see that we have all few elements left in this, so we will be pushing that out, popping that out, and again we will comparing. So in that, for next term, our b is going to be our new a. So a is going to be 4 and b is going to be 3. Same will be applied and we will find out 0. For next term, we will be popping out 2, then our b is going a is going to be 3 and b is going to be 2, and again 0. So we will repeat all this and we'll find out that our result is going to be equal to 0. Okay, so now we got an idea how we can solve this problem. I want to look at one more example so that it can become more clear. So let's say we have something like this. Okay, so just pop it out all the indexes. So we'll be at index 0, we'll be pushing it. Index 1, we'll be again pushing it. Index 2, we'll be pushing it. Now we are at index 3, we have a close parenthesis, we will be popping out 2. Again we have close parenthesis, we will be popping out 1. Again we have open parenthesis, we will be pushing it, that is 5, 0, 1, 2, 3, 4, 5, 6, all the open parentheses, 7, 8. So we'll be pushing out. Okay, now what we can see that we have 8 at top and our stack is not empty. So we'll be doing same method that we have applied in previous problem. We will be n equal to 8, n equal to 9 in this case. So 9 minus 8. So we had this one, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we'll be popping out 9 minus 8 minus 1. This is going to be 0 at starting. So our result is for now is 0. Okay, now this is our a and this is b. So our a is going to be for next term 8 and b is going to be 7. Now we will be having result 0, a minus b minus 1. Okay, so again we will be our result will be 0. For next term 7 is going to be our a and 6 is going to our b. So again will be our result will be 0. For next term 6 is going to our a and 5 is going to our b. So our result is going to be 0. For next term 5 is going to be our a and 0 is going to be our b. Okay, so minus 1. So our result is going to be 4. So we can see that we have a result 4 which is greater than our current result. So we'll be updating that using max method. So our result is going to be 4 in this case. Okay, so we can see that we got our result in this case also. So now I think we have got an idea how we can write our algorithm. So what we'll be doing, we'll be iterating through iterate through all characters and push index when found open parenthesis and pop when found close parenthesis. Okay, but there can be case that we have only close parenthesis. What we'll be doing? We will be simply inserting the indexes of this, or we can say that we can skip this part. In that case, what we'll be doing, when we found out that our stack is not empty, sorry, our stack is empty, we will be pushing this, and next time it will get popped. So in this case, if a stack is empty and current char is close parenthesis, then push index up also. Okay, so this is the first step, and then we'll check if a stack is empty. After this, we can say return length of string. How we can return length of a string? Because we know that if we found that after doing all the operation push and pop, if our stack is empty, that means all the parenthesis was valid. So we can see that for case 3 and 4 our parenthesis was valid, and when in this case we found that our stack is empty at last. Okay, after that, what we will be doing, we will be doing a equal to n and b equal to 0 at the beginning, and then we keep popping and keep checking that what is our maximum possible result. So for that we will be needing a variable that is result. Okay, so we can declare this result at beginning also. Here will be 0 at beginning, and then we have to run a loop. So for that we will be doing run a loop or iterate until our stack is not found empty. Okay, so we'll be running a for loop, and then after that what we'll be doing, we'll be updating our, so we found that b is going to be inside this for loop, what is going to be or something like this. So b is going to be a stack dot top element, that is a stack dot pop, and we will be updating our result, which is going to be max of result b, sorry, a minus b minus 1. Okay, and in every iteration what we have to do, we have to update our a using b. So a is going to be our b. For next iteration our a is going to be b. Okay, and then at last return result. Okay, so this is the approach that we have to follow and write the code for same. So what we can do now, we have to go to compiler and write the code for same. So let's go. Okay, so we will be going to need length of a string. So n is going to be length of a string, that is s dot length, and we have to return a result in integer form. So we'll be assigning that also. Result is going to be 0 at beginning, and we are going to need a stack. So let's create a stack of integer. Okay, and then we have to iterate through all the characters. So for that we will be using a loop, which in this case it is going to be for loop. So we'll be starting from 0 and going to till last index. Okay, and if s dot char at I is equal to funds open parenthesis, what then in this case what we have to do, we have to insert that index into our stack, a stack dot push I. Okay, in else part, if we found that our character is of close parenthesis, so first we will check if our stack is empty or not. So if we found that a stack dot is empty is true, in this case, so if we found that our stack is not empty, then only we will be doing pop element pop part. Okay, so in this case, and then we will be checking if a stack s dot char at s dot top is going to be equals to close parenthesis. So if the top character is going to be close parenthesis, in that in open parenthesis, in this case what we'll be doing, we will be popping that out from our stack. So in this case stack dot pop, and if we found that our top character is going to be close parenthesis, that is going to be handled in else part. So in this case we will be pushing our current index also. Okay, so this is going to be happen when we found that our current character is close parenthesis and our stack is not empty. So what if we found that our stack is empty? In this case we are going to handle in else part. So in this case also we have to push our current index. Okay, and if we found that our stack is empty after that push and pop operation, then our result is going to be equal to n in this case. Okay, in if it is not empty, then in this case we have to do some other operation and we have to check that our what is going to be our greatest result. So for that we are going to need a correct another variable, that is a equal to n and b equal to 0 at the beginning, and inside this we will be running a while loop until unless a stack is not found to be empty. Okay, and then what is going to be our b is going to be top element of a stack. So for that we will be doing stack dot pop, and then we have to return our result. So for that we will be updating our result. This is going to be max result b minus a minus 1, sorry, a minus b, because a is greater than b, so a minus b, and for next iteration we have to update a, this is going to be b. Okay, and at last we have to again result is going to be method.max result a minus b minus 1. Okay, and now return result. Okay, run this. Okay, so we use this top function. So as we are using Java, we have to use peak, not top. So it's okay, no problem. Now, sorry, we are using a stack, so stack.peak will be applied. Okay, now so all given three test cases has been passed. I hope we can pass all the remaining test cases also. So now submit this. Okay, so it should not be a minus b minus 1. This should be a. Now submit again. Okay, our solution has been accepted, and this is one of the most optimized approach. You can try another approach also, but this is going to be fine for this problem. So I hope you must have learned something from this video. In that case, please make sure to like the video, subscribe to the channel, and don't forget to share this video among your friends. Thank you.